Welcome to the Calculus B section. In this section, we'll be discussing areas between curves. Now that we've learned how to find the area under a curve under a definite region or indefinite region of a singular function, we can now try to find the area between curves as illustrated in these two scenarios. So here on the left, we have the bottom function denoted by g of x and the upper function denoted by f of x. They are both in the same quadrant, which means the area between them would entail a subtraction from one another. Additionally, we are looking for the region from A to B, so we can label this A and this B. Now, the integral reads as such. The area between the two curves is the region from A to B minus the difference between the upper curve subtracted from the lower curve dx. Now this makes sense because let's say we had a curve here and a curve here. We want to find the difference between the two curves in this region and integrate over it. Now let's say we had the situation on the right hand side where this is B and this is A respectively, and we wanted to find the integral between the two curves from B to A. Now if we said f of x minus g of x, we'd run into a problem because that is the difference between the two curves. However, that would look something like this. That would insinuate that the curve g of x is above the x-axis, but because the g of x curve is below the x-axis, we can state that the function is actually a negative function. So that means that the integral from b to a would be f of x minus negative g of x dx. This means that we will actually be adding the two functions, which would give us a greater area, which is depicted in this graph. Now, when we integrate between functions, all we're doing is finding the difference between the areas and doing it with respective regions. So let's say we wanted to find the integral of the area between the curves rad x, square root of x, and we'll just say x squared. So what we want to do here is we want to find where these two functions are equal. So we can say that x squared is equal to rad x, and we can square both functions. We get x to the fourth is equal to x. We divide over an x and we get x cubed is equal to 1, which means that x is equal to 1. Additionally, we know that x is also equal to 0 because 0 is equal to 0. So we know we're integrating from 0 to 1, and we know our two functions are rad x and x squared. When we think about these two functions, we can say that x squared is going to start off lower than rad x, and they're going to intersect at 1, and they're going to be at the same point at 0. So we know that we're subtracting rad x from x squared. So our setup integral would look something like this. The area between the two curves would equal 1 to the 0, rad x minus x squared. And we're really only concerned with the setup here because you guys are masters at integrals. So we know that our integral, the area, is going to equal to 1/3, but if you would like to solve that on your own, I encourage you to do so. If you need more help with the problem or more problems to do for areas between curves, there's a bunch on the website. I hope that helps.